Hello everyone. So we will start the second panel of the day, and this is the last session of the conference as well. So this panel is about automotive. We talk a lot about automotive. So here we try to discuss around how we address automotive with new standard around functional safety. And this really range, broad range of discussion around verification techniques, from ESL to various models, and how we can work and how they can be used to address this new challenge around automotive. So in the panel today, we have a lot of brilliant people here to discuss, and I have the honor to have Paul, who will moderate this panel. So I leave you, Paul, to start and to introduce yourself and the guys. Thank you.
Thanks, Trent. Hi. I'm Paul Dempsey. I am a correspondent for E&T, which is the magazine of the IET, and also I edit the Tech Design Forum website, and we're one of the sponsors of this event. Now, my job, as you can see up there, is really to stop talking right now and start throwing things over to the people who actually know what they're talking about. We've got an interesting panel. I'm going to introduce each person as we go across. We're going to start with Bill Bunton. Bill's got a background working in virtual prototyping at the moment over at Intel. We have Ashish Darbari. Ashish is the founder and CEO of Axiomise, which is a specialist and an evangelist for formal verification. I think you won't mind my saying that. We don't seem to have the slide in for you, sir. Would you like to introduce yourself, perhaps?
So my name is Ralf. I'm a system architect for battery management systems at NXP. I think I sent the statement as well, and that was, I don't remember exactly, something like, so we need to get better fault injection mechanisms and fault injection simulators on a high level, so get them away from the gate level netlist to something which is closer to the function that should be safe, and not only the low-level hardware.
Okay, now, next we have Dave Kelf. He's the CMO at Breker Verification Systems, very closely involved with PSS, which I'm sure a lot of you have been attending the sessions about today. And finally, we have Jamil Mazzawi over at Optima Design Automation, and he's also going to be discussing fault simulation and some of the problems that we have there. Now, for the purposes of this panel, and because we've only got around about 40 minutes, we're going to take the benefits of all of these technologies as read. So, I mean, if you're at DVCon, you've probably got an idea what PSS or System C or fault injection or any of those things are. You probably already have some idea of how important they're going to be in terms of getting towards level 5 vehicles for automotive. So the first question I've asked the guys to prep is, looking at their own specialist areas, don't give us the backgrounder, but tell us what's happened in just the last 12 months, since the last time that we were here, that you think has taken your technology further along, made it more automotive ready, if that's what way we can start. So, Bill, do you want to maybe answer that one first?
Well, I'll try to answer it. My area of expertise is virtual prototypes and System C. And the big things that have happened since System C recently are the completion of the configuration specification, and we're opening up work on the inspection portion of it. And these will support virtual prototypes in the testing for the standard.
Okay, so we're seeing progress there. Ashish.
Yeah, so it's a very interesting question, Paul. So I used to work for OneSpin before I started my own company, and if I'm not wrong, they were one of the first to come up with a safety solution. And what I've been noticing in the last year specifically is there's a lot of settling down happening with the number of EDA companies already having, they had fault simulators, they had other solutions, but they're all coming up with new ways of solving the problem, and a lot of them are actually using formal under the hood. And a lot of apps-based suite is an offering consistently from all of the big three and OneSpin. But equally, on the user side, what I'm seeing is a lot of maturity coming in the user base, where companies are catching up with understanding of what it actually means to build a functionally safe design linked into an automotive ecosystem. At the same time, the requirements in ISO specification on tool certification has caught up. So whereas previously the vendors had solutions but not certified solutions, they now have certified. So the TÜV SÜD certification is in place. So I think it's all happening, but I don't hear that much buzz in the last 12 months in the safety. I think because people kind of are getting used to what is available in the market and are now getting to use it, as opposed to a lot of new things coming out, but I may be wrong.
Okay, Ralf, your take on this. What's happened lately?
It's not exactly lately, but the new release of the ISO 26262 is good for us as a semiconductor company, because it explicitly talks about semiconductor development and gives more detail on the safety element, also out of context development. And what I see that we get more mature in working with these things, better alignment on how to handle fault analysis, how to handle safety, and how to as well get a consistent pictures for our customers what we do in terms of safety and to prove that we are safe.
Okay, Dave?
Yeah, so well, about a year and a quarter ago, the portable stimulus standard was released by ASIL-A, which inevitably had the effect of shifting that from a proprietary language into a mainstream standard, and therefore a lot of companies jumped on that and said, okay, we need to take a serious look at this. And I think one of the effects of that was, and then maturity is a good word for it from both you guys, it was a movement towards away from just, hey, there's a new way of creating tests, towards, which kind of vertical segments can really benefit from this. And inevitably, a hard look was taken by a lot of the automotive companies, and a lot of benefit was found to expressing requirements in portable stimulus and then running them down around the V-loop and then applying the coverage that's available through portable stimulus that's much more powerful than you can do in other methods. And using that to complete the systematic flow in a much more effective way. And then once, of course, you've got a good, strong test bench, applying that into the random flow as well. So I think we've seen a lot more of that, a lot more practical benefit of portable stimulus, and actually a lot of the technologies here, as both of you guys were saying, maturity and so on.
Okay, Jamil.
I will first second the Ralf regarding the standard that got released end of last year. It's very important now we have edition 2 of the standard, much clearer than the previous version. But what we also see is that the automotive semiconductor is expanding. We're seeing more and more projects inquiring about functional safety, fault simulation, and more engineers getting into this, learning functional safety and wanting to learn more. Historically, I think there are a few companies, maybe NXP is one of them, is with leadership and expertise in functional safety. But now this is expanding to having more smaller companies going to this.
Okay, great. So as we can see here, there's been a lot of maturation across a lot of areas, and I could throw in things like emulation, high-level synthesis, all of these kind of things as well, taking place in the last 12 months. So this is where we get evil. Adding one new technology to a flow is difficult. Adding a whole lot of technologies to a flow is a nightmare. Now, from what I can see, to achieve the kind of results in verification that we're going to need in automotive, we're going to need pretty much everything that you guys have talked about and more. Now, some of the people sitting out there, they're not just thinking about one thing, they're thinking about multiple things and how they manage this process. Now, we've got a couple of users here, we've got some vendors here, we've got a consultant here, and I'm going to ask them, basically, how do you put all of this together? Because what we're talking about here is not the technologies themselves, but their application. So I don't know if anybody wants to jump in first and has some thoughts on this, but how actually do you adopt so much in a flow when it all seems to be essential and it's all coming at you at the same time?
Yeah, I could have a go. So I think in the early days of functional safety, a lot of people were focusing on random faults, and they became a big deal, and a lot of solutions that came out were on random fault coverage and fault propagation analysis. They then took a step back and said, hey, we're having a lot more design bugs in the first place, so what's the point of chasing these? And a lot of our time is getting spent finding systematic faults. So I think now they're taking a step back, and some of the mature vendors, they're saying, let's not talk about systematic or random in particular, let's talk about a functional safety verification plan. What are we going to do for functional safety, period? If that means it has to be done in simulation or formal or emulation or everything, that's fine, but let's write down requirements, what we need. And I think it's interesting, someone said, I don't want to do this at the gate level, but only at the RTL level. I think it was you. But I think they want to think about it at the whole spectrum, whole abstraction stack, but it would be good to consider how to do this early on. And if you can put functional safety as one of the essential verification requirements, then what you would see is that a lot of usual standard verification, if that was done well enough, would actually not introduce a lot of extra work for you. It would only mean that finding systematic faults is now a lot more better because we are trying to aim for a higher standard as opposed to trying to ship it anyways and then release patches later on. So I think that is a change in the mindset that I think companies are beginning to have. Is it's not okay to ship it and patch to the ECOs later on, but actually take a step back and design things upfront in a way that actually we have to do less work downstream. So it's a change of culture that is coming, and I think the mature guys, the companies who are actually linked directly into the automotive ecosystem already know this. So I'm not sure that it is a lot of extra work. Of course, the analysis on random faults, it is, but a lot of the systematic fault effect, I think, would be taken care of naturally. That's my view.
Okay, anybody else want to jump in on this?
Yeah,
Jamil.
No, I used to work at Veracity in the early days when we kind of created something new, which is random-based constrained random simulation. Then the need for this was coming from, let's say, from the people, from the designers, because they are working on bigger and bigger designs, and using directed random is not doing it. So it was obvious when Veracity came with the solution for constrained random. People adopted it. It took time. It was a mind shift that they needed to do. And now this methodology became more and more popular. There's ERM and UVM and so on. If we look at this point of time, it's in a way, it's similar way, but the change is coming in a way from the outside because you have a standard that you have to comply with, and there's a requirement coming from the standard ISO 2662. And there is now, at this point of time, I think there are many different interpretations about what the standard means. What should I do? How should I deal with this? How should I deal with that? Some companies are maybe more mature and they know the answers. Some companies are less. The whole industry is debating what does it mean to do this like this. It's not obvious what will be the best solution, the best methodology. If we think about 5 years from now, I think the industry will start to stabilize about best known methods and methodologies about how to deal with this. So I think there is industry-wide shift that's happening from no safety at all into known methods for functional safety. And everybody here in the audience, I think, will be participating in this new revolution, let's call it.
Yeah, I think I would fully support this, both of you actually. On one hand, the bottom-up analysis proving that things are right in the end of a project is very important, but it will not work to do only that. You need to follow the systematic approach from top down, decomposing your system, try to identify the issues early and partially as well in a theoretical paperwork style, and not only for the design but as well for the methodology. Think first, what do you want to prove with which tools, with what methodology in the end, because you need to plan it. Coming up late in a project with something that you never tried before will not work, and so on. So having this think first and plan activities on one hand, and the other hand, the standard does not only talk about what you do, but as well as things like way of working and implement a safety culture in the organization. This is a very important part to have arguments against heavy time pressure and things like that, and heavy cost pressure, because this is things that are for sure important. Keep the timelines, keep the costs under control and things like that, but don't jeopardize your safety concept by these parts.
Yeah, if I may, I mean, at the end of the day, right, to get back to the original question, it's all about ROI, and we all know that. The return on a good safety methodology is enormous, right? So if you look at the history of this, a bunch of companies came in, and they said, well, it's fault simulation, so we'll just take our 30-year-old manufacturing fault simulators out of the cupboard and try and get this working. And there was kind of this period of getting this sort of moving. And then some companies came in, and actually I'll shout out to OneSpin as well, who I also used to work for. OneSpin was looking at how can we improve this flow, and many of the other companies were as well. And I think there was this realization, as you say, a shift of, no, this isn't just something you can just throw in at the end of the process with a 30-year-old fault simulator. You've got to use new technology, special purposely built for this. You've got to put in a flow that goes right through the whole process. And we've got to get away from companies who are kind of like making some educated guesses, let's face it, at fault analysis in general, and get to a much more rigorous, much more well-defined process. And I think that's where we're at now. And that's why this panel is so interesting, right? Because, I hope it is. Because here we are with a bunch of new tools. It's very interesting, come on. But we have a bunch of new tools and a bunch of new ways of applying them. And we're starting to see the result of that now, together with the culture, with the process and everything else in place. Okay, shut up, Kelf.
Bill, you've been quiet. When we were talking before, you said you're the person who doesn't really have a dog in this hunt. So you listen to these guys. I mean, as someone who can sort of like take that step back, I mean, what do you think of what you're hearing?
Well, the thing that hits me first here is that we're focused on the components and not the full system. The system is what counts, and the people interacting with it, and the software that runs on the hardware, and the fault isolation within the hardware components. So that looks like a piece that really needs to be addressed, and I haven't heard anybody attacking that. And when you get to the point that you've done this, then you can go in and create faults at the component level, see if they're contained, see if they're reported in a way that is correct for the system at the end user. So is the driver of a car prepared for, let's say, half of the brake system failing? What's the automation going to do with the front and one rear brake? How is it going to behave? So that's something I think has to be included in this, is the full system from the user to the end.
This is part of the safety plan. This is where we were saying that it all has to come from a functional safety perspective. I'm not hung up on hardware versus software. I'm all in favor of what you're saying, taking a system view and taking a feature-oriented view of use models. None of this is that much different from how SoC designs used to happen before and verification. But I think if you don't have a culture of doing this top-down, as you're saying, but also bottom-up, and if you're literally relying on making copies of the old designs and then hacking them somehow to fit the new use model, and if it's not becoming a blueprint approach, which is how conventional engineering actually is done. We have blueprints. I was an electrical engineer. I was having SOPs, standard operating procedure. ISO 9000 mandates say what you do what you say. So none of this has been that much new, as it's not come from Mars. But I think for hardware and software industry, all of this is new, especially from functional safety. And I completely agree with you. We need to take a use model point of view, but we could do all of that analysis, but if you're not going to implement it in a systematic way, it's pointless, right?
It's soup to nuts. You've got to have the whole package, or you failed.
Yeah.
Okay, sorry.
I think this is a huge challenge as well for verification then, because the errors happen in the very low level. So you have a bit flip in a register, some signal being infected, whatever. But this is not your issue, because there is a whole stack of safety mechanisms, and hopefully one of them will catch the error. But the function happens on the very far end of the same system. And this is what we need to protect. And all the way in between needs to be covered. And this is a complicated analysis topic.
I would just add one sentence here. I think there are two challenges here. Is that if you look at the chip level, the problem of functional safety is so huge now, just thinking about chip level. And even some companies try to attack only unit level, so not even think about full chip. And system level, I think it's very important, but it has first capacity problem. How can you deal with the capacity of doing system level? And the second challenge, which is more serious, is how can you take a software written by somebody at Mercedes or Bosch to run on a chip done by NXP and simulated by some EDA company. It's huge. How can you make the IP from different companies meet in one place and do simulation? This with time, I think the industry will overcome IP issues and do this marriage of one place where these systems are meeting and talking together.
Okay, so I mean, let's follow on from that, and let's ask a very blunt, very non-technical question. You might say that a lot of this thing is, everything old is new again. Okay, I can see some of that, but where are the skills to do this kind of integration? I mean, there are obviously skills in all the different technologies, specific technologies that you guys work with, but certainly one thing I'm not seeing is a lot about how you do integrate everything to get that system level view. I mean, in simple terms, how many people do we have out there who are capable of doing that? And if we don't have enough of those people, can we ever have the kind of automotive autonomy that we're going and getting hyped all the time?
If you ask me, I think
I'm asking everyone. Anyone wants to talk about the skills? Anyone who wants to talk about the skills?
I think there are people with that skills, and if you solve the IP problem, the other things will be easier to solve. But the question, how can you get the right software with the right stimulus from the system people, which are the OEMs, to work on the chip that's done by Semiconductor? I think this is, and there is the tier one in the middle also. So it's a huge problem from the IP perspective, I think. But finding the right people shouldn't be that challenge, because we have people who do system level emulation and so on, so it can be done.
Okay, I mean, this is a short session, so I'm going to actually open it up for questions in a moment. But I mean, I'll throw maybe just one quick one at all of you guys. We've talked about the new issue, the new release of 26262. And we're looking at compliance issues that are important here. I mean, what would you say are the most significant aspects of that new release? I think we touched upon a couple of them earlier on, but I mean, what are the watch out things? Because I know there's going to be a meeting here, I think, next month. And I think there's going to be an open day session that's being organised, which I'm kind of giving a bit of a plug to as well. But I mean, what kind of things should we be watching out for there? As you say, semiconductors are now in there, but what else is there to keep an eye on? Anything in particular?
So I think one important thing is the differentiation between a qualitative and quantitative approach. Whenever you want to go higher ASIL level, like ASIL-D and ASIL-C, you want to go with a quantitative approach, and that's, I think, one important part that we're looking into. How in Optima, we pride ourselves in having very fast fault simulations that can take care of bigger and bigger designs and go for ASIL-D with a fault capacity.
Yeah, and I think the shifter systems as well, right? Yeah. Since we've all touched on that, you can see that throughout that whole new standard. An emphasis on how do we take a whole system on chip, and what do we do at the block level, what do we do at the system level, where do we start in the process, and all these kind of things. Much more focus on that than has been in the past, which has been very much block level. How do we check the safety mechanisms in the block?
Yeah, if you bring in high-level synthesis into it, and the urge to do this more high level, and then are the tools going to be able to simulate the high level, or the impact of this on the timelines and the safety plans and so on. I think that's what a lot of these challenges are. But I would go back to what I was saying. I think a lot of the hassles that people see downstream are often due to a lack of good systematic verification upfront. Whether the plans and the needs, what is getting verified at the IP level or a component level, whether it's derived from a system level verification plan or an SoC level or a CPU core level, it's besides the point, but somebody still needs to make all of this linked to the top level plan for safety. And that linking is a big process overhead. That I totally agree. That a lot of the overhead in accomplishing the goals of ISO 26262 is in process and documentation.
Okay, so I'm going to open this up to the floor. We've got about a quarter of an hour left. Does anybody have any questions that they would like to throw at the panel? Come on, you're not that desperate for the free beer.
Okay.
Yeah. Hang on. We have a mic. If
So, okay, working. I'm taking a slightly different position. I'm hearing the core for this whole integration, and we want to basically simulate from the bottom to the top and vice versa. But the standard allows us to define something like system safety elements out of context, right? And that gives us the ability to define or build a chip which can be used then by an OEM. And what I would like to hear from you is, how do you see that? And should we not rather focus on the interface, so we have a good standard on how to define what the safety element out of context is and what is the interface an OEM would use, the information would use, rather than calling for this whole chain, because that's very hard to implement.
I think NXP is a good example. We're doing basically only safety elements out of context. But yeah, out of context is a strange word, because we always need to consider the context. And we need to consider the application. And we need to prove that our assumptions are good. We need to prove that all we think about the environment is good. And in the end, we always need to consider the application using our ICs. Because they often do not use all the features, all the area, for example. Then we need to adapt the quantitative analysis on this. And in the end, we need to support the application for doing whatever the application wants. And we cannot always think out of context. So we always need to have the functionality in mind, because that's what needs to be safe in the end.
Yeah, I mean, I see it just reflecting verification in general, right? So if you look at verification in general these days, the whole system on chip flow, you start with some analysis and architecture work at the beginning. Then you do a whole ton of block level work, and a lot of the UVM type testing and formal testing is done at the block level, getting the block level working correctly, right? And once the block level is fully verified, putting it into a system on chip and stitching it together tends to be the verification of that tends to be more infrastructure, cache coherency, and that kind of thing, right? So if you want to take a block out of context and get the safety mechanisms and everything working with that, that's kind of fitting into the regular verification flow anyway. I mean, it adds a lot of overhead to it, but I think that's where they're sort of coming from with that. That's as I understand it.
And even also, half of our safety mechanisms are external, so someone else needs to pick them up and prove or implement them, or they implement a certain part of these safety mechanisms. And so, yes, we think out of context in a certain sense, but we cannot reduce ourselves to our IC. We need to keep the rest always in mind.
But the interface is a good point.
Yeah.
I mean, we definitely need the interfaces to allow you to plug those together and to pass that through, right?
The assumptions you make, right? How do you pass the assumptions up
Absolutely.
to the OEM you made?
Yeah.
We have all safety manuals for sure, but
they need to be validated. Yeah.
Safety manuals, they're all different.
But this is part of the problem, right? This is why we need to rationalize all that and standardize some things.
And building something that works in the right context is hard enough. Not thinking of it working out of context is like a Wild West, right? I mean, you could still work with the OEM to scope out what are the different use models, but just defining what are the precise ones for which you need to build something is hard enough. So yeah, good point. I don't have a good answer. Sadly.
So I think this is a very interesting question, because with time, these problems will be solved in a nice way. But now we have like a safety manual, which is more is document. But imagine in the future if we will have some kind of executable safety manual, where the user of the chip will say, here's my configuration that I'm using the chip in, and then this will spit out new FMED process and safety manual specific for this specific configuration, and then. So at some point we have to go there, that a semiconductor company will deliver some kind of executable safety manual that's based on the end configuration. It will change.
Okay, anybody else have any? Sorry.
But we can have...
Any more questions? Sorry, a little light in my eye here. Yep, Martin.
I remember, if I go back 10 or 20 years in time, we had movements which were called the DFT, Design for Test. We did test, we had to do debug, wire here, wire there, and at some point in time the industry thought, perhaps it makes sense to have a sort of test interface, and we need to put some dedicated stuff and align on a methodology and IP blocks even. In order to facilitate better, robust and more streamlined design for test flow. Would it make sense to think along those axes, that we think, hey, design for functional safety, do we need to have IP blocks with a dedicated interface to communicate functional safety intent throughout the SoC, throughout the network on chip, throughout the entire car? Any thoughts on that?
I think for the some of the technical sides, there is good kind of alignment, not necessarily standard. So I know exactly what a CRC can do, and part of this is as well covered by the ISO standard. But when it comes to exchanging documents and so on, there is a lot of PDF, and so we have this idea of executable safety manual and so on. So. It would help to align better there on these ends, to improve automation, to improve exchange, and to have standardized ways to solve certain problems. Because so a lot of these problems are default problems or are similar to several products and several companies.
So you're talking about building extra hardware for diagnostics and being able to facilitate debug?
Yes, and align across the industry and partners on that.
Yeah, I mean, it sounds like a great idea, but we also have to make sure that this can't be exploited for security type problems later on. But certainly seems to. But the other thing is, even if you were to build that also has to conform to the same standards. So that means extra work. Maybe if we find a middle ground and maybe get away with a very well-defined interface for debug safety, and then that could potentially be a more uniform interface that could be plugged. Sounds like a good idea.
This interests me in that we keep talking about it as if it's a system on a chip, and that chip is the only thing we need to be concerned about. There's faults in that chip. Most of them will probably be contained to that device. But if that device propagates bad information into the rest of the system, how do we deal with that?
So they already have probes, right? So if the car breaks down, the guy comes to the laptop, plugs it in the interface, and he's able to do some initial diagnostics. So they're able to come up with a good understanding of what has gone wrong if things do break down. But I think if you're talking about faults manifesting in a dynamic system when a car is running on its own and then trying to find the effect, of course, the source point of investigation would be a laptop again, to try and get a whole trace out from the system and the software. And then
I'm more interested in the real-time environment.
Yeah.
If the fault is identified, that there's a fault, then you can go diagnose that fault, break out smaller components in the system. But how do you deal with it at the system level with a vehicle in motion?
So you'd be passing over all this information up the stack all the way to the software level, right? That's the only way to track if things go pear-shaped. I think if the faults are automatically getting corrected, then the hardware will take the corrective action and the software wouldn't have to do much. It's only when things fail catastrophically and then software had to kick in and still couldn't rescue, then I would imagine a well-designed system would be able to transfer all this information down all the way to the software layer to allow debug to happen. If it isn't happening, then I'd be surprised. But from my experience of driving some good cars, if they do break down, then my understanding is, there are ways to unearth all of this information out through a simple laptop that these guys bring.
But that's all too late, isn't it?
Yeah.
I mean, that's all the car's crashed by then.
Yeah.
So what we've got to look at is how do you do the modeling of this? And maybe this is where you're coming from, Martin, I don't know, but creating sort of higher level layered models and having interfaces from those models into the tools and making sure we're all talking the same language in terms of like system level faults and more advanced level faults than just regular stuck at ones and zeros and what have you, right? I mean, is that where you're sort of going? And then you accelerate sort of working group? Or?
Yeah, that's right. That's what I want to say. Yeah, I think Paul was hinting at it, right? So Accelera announced yesterday, October 28th, so yesterday. Which country is I? Yesterday or day before yesterday, I don't know. 3 days ago. It's not my time zone. But essentially, interoperability working group.
Sounds like it is.
Sounds like it. Yeah. Thank you. The interoperability working group with respect to the safety intent. So this is kind of where I thought Martin was going. I actually noted it before he said it. Just like design for test, design for safety, capture the intent. So I like the whole what Anish and the team was pointing out, the top-down approach.
They got my name wrong. I'm Ashish.
Ashish, okay.
Without the leading H, by the way.
Slap your tongues over eyes around. So I think that interoperability is important. The thing which strikes me in there, and I think that's probably a suggestion for a panel next year, when I talk to kind of the likes of LDRA and so forth, who do these things on the software side, they're doing very similar things, like looking at safety intent and so forth. But I think the key is the interface, which the gentleman in the front here mentioned, said, basically saying, how do you bring this together, hardware, software? So getting your thoughts on kind of the standardization and the Accelera working group would be great as a context of this panel.
So I think what you're referring to is something that must happen, but maybe we're a little bit too early, not now, because the ISO 262 was just released a few months back, and different companies now are experimenting with it, trying this, trying that, you know, what I mentioned, like executable safety plan, also is part of this. It needs to happen, but if you put the standard before the engineers, the community has done enough experiments, try this, try that, it can be wrong standard. So I think we should give ourselves as community 1 year or plus or some more to experiment, and then to go into standard like this, which is, it must happen. You know, how to transfer information from one level, from the IP to the unit to the SOC and then system. This is something that must happen to be executable and must automated.
Dennis wants to come in here.
I've got another comment because I don't think you have the luxury of time. In addition to what Accelera announced, your leader of ISO 26262, Riccardo Mariani, he's accepted some roles within IEEE, have been elected, and they are starting a companion standards operation as well that mirrors what Accelera is doing, and that will probably be the basis of further discussion a month when you all return to attend that meeting. So you may want the luxury of time. I don't know if you're going to be offered it.
Okay, I mean, if it has to happen, I think it has to happen, but you know, if you do it after the industry has experimented a little bit, it'll be better standard. If some people are rushing for it, okay, we'll do it.
It's an issue.
Yeah.
We may be late, right?
And this is one standard you don't want to get wrong.
Exactly.
You really don't.
It does affect all of us.
Yes, really. Yeah.
Okay, are we going to need more? We've just got a few minutes left, so any more questions from anyone? No? I mean, I've got an incredibly banal question I'm going to wrap things up with, so please do something. Oh, sorry, we've got this gentleman here. I do apologize.
I got one question to Ashish. What is the future of HLS in automotive designs, high-level synthesis?
What is the use?
Of high-level synthesis.
There's a lot of companies who are actually exploiting HLS for arithmetic and DSP type applications, and I'm pretty sure that they're going into automotive. So if you were thinking of verifying a system, and then you need to have an understanding of what tools you're going to use, how this verification is going to be done, whether you're going to just verify the extracted RTL or you want to actually address this problem at the system C level directly. I think it's a bit of an unknown, and I'm in the middle. I don't care if they use HLS or don't use HLS. You know, from a verification point of view, we need to make sure that the requirements for safety are met. But it certainly has a bearing on time and process.
And how good is system C and UVM integration so far?
How is it with UVM?
UVM integration.
I think that's the only thing.
On paper it looks good, but on the practical side, I'm still not in favorable mood.
I'm not an expert in System C and UVM, but I know that actually UVM still works for System C as opposed to, I think some of us have tried using Formal for System C, and I know back in the days when I used to be at OneSpin, we were certainly engaging with customers who had interest in applying Formal. I think it's a bit of a gray area. I think most HLS vendors are not providing the end-to-end test benches, so I think the end user has to rely on their own test benches, and that could be a bit of challenge.
Yeah. But I think, so there are people using HLS in automotive, right? So Renesas and XP, I think, if I'm not mistaken, are using System C, and they're using it for like architectural design, more for sort of DSP type applications and image processing, that kind of thing. Getting that architecture right first, and then passing that over to the, as I understand it, to like the RTL System C, System Verilog sort of level. So, you know, as we talk about bringing automotive safety into that sort of architectural level, the question is, where do you start building that into these architectural models for sort of some of these DSP functions as well, which is going to become important.
Because you don't want to retrofit it once you get...
No, absolutely not.
Ideal, right?
No,
So
that'd be a
you need
disaster.
I mean, it sounds like when they're talking about HLS here, they're looking at the use cases that are already fairly mature elsewhere. I mean, you're talking about images, computer vision, I think that kind of thing.
Yep.
HLS is being used outside of automotive pretty widely for that, so it's easier to import it with some best practices.
Yes,
indeed.
And the vision and stuff like that, right? Cameras.
Okay, we have reached the end of the road, and the free beer awaits you. Anybody does have any other pressing question? Other than when will that man stop talking, because I'm thirsty? Okay, well, I would just like you to thank our panelists here. It's been a very, very lively discussion. Thanks for attending this year's event. I believe that there is the best paper ceremony that's taking place over in the exhibition area, if I'm correct. And thank you very, very much for coming here today.